Today we're presenting CNES challenges, and it's Walter Dieudonné who will do that, and we'll have time for Q&A at the end of the challenges. So that's where we are. And Walter, I give you the floor, and thank you very much for your presentation today.
Thank you, Magali. Hello, everyone. So on the behalf of CNES, I'm going to present 10 challenges. They are very broad. They're very ambitious. There are a lot of subjects to cover. It's pretty exciting. So I will present a movie we have prepared with each challenge, and at the end of each challenge we're going to have a small pause, and if you have any questions then feel free to ask them and I'll be happy to answer them if I can. So with no further ado, let's start the presentation.
Deploying hope. Versatile solutions for Earth and beyond. The goal is to get antennas that can be adapted to whatever environment they find themselves in, whether it's a high-altitude platform or a terrestrial communication point. These antennas are designed to be indispensable and effective for complex orbital communication, rapid disaster response, or specialized terrestrial networking. These systems must be robust to ensure reliability. This is needed for mission continuity, reducing the risk of failure. For space, these deployable systems are designed to be the communications lifeblood for orbital assets. They can be mounted on small satellites or integrated as large, high-bandwidth communication arrays on space stations. On extraterrestrial habitats, these antennas are not temporary. They are permanent infrastructure. They'll handle everything from real-time communication between astronauts and mission control to scientific data downlink. When major catastrophes strike and traditional infrastructure fails, these antennas are designed for rapid deployment to restore essential communication networks. They can quickly be on the ground to support first responders, coordinate relief efforts, and reconnect communities. This translates directly into lives saved. Your challenge is to outline the specific areas and locations where you would take action, including the key stakeholders involved and your target audience. To describe your business strategy to ensure the success of this venture.
So this was the first, okay, let me go back. This was the first challenge. So the idea is to, sorry, this will be better. This was the first challenge. It was about antennas that can be deployed and used on a autonomous manner. As you heard, it can be used in many areas in space, on remote planets, on Earth. And in terms of startup company, you can really think of many uses and a pretty wide market. So if you have any questions now, I can answer them.
It's really the time to ask. If there are no questions, we just go on to challenge number 2. But if you want some specification on that, please go ahead.
Hello, Lex from Taiwan again. Water, is that pronunciation correct? Water.
Yes.
May I ask, how do you perceive that participant? How do they show that they have a deployable antennas designed for the competition.
Can you repeat, please?
How do participants, well, present their ideas to show that their antennas are deployable? Since they only have like 24 hours, do you have any suggestion or ideas or how can they present their ideas better?
Okay. So you mean about the technology? Okay. Well, the idea really is not to invent the technology. Huh? The technology of such antennas, it actually exists. That's why it's and it's being worked on by CNES. That's why we chose to present this challenge. CNES has worked on such systems with basically antennas that use super elastic materials, and these materials basically they don't need power, or they don't need heating to go from one shape to the other. So the technology actually exists. What we expect really for people is not to invent a technology from the ground up. It's really to do a search, on what's available, from that search to take ideas, to extend those ideas. So as I mentioned, for example, using super elastic materials, there is, if you look at, for example, the European Patent Office, EPO, you will find plenty of papers on such deployable antennas from CNES. And again, the idea is to see how it can be used and to basically find how to market them and how to enhance maybe the existing technology.
Yeah. Thank you. That's yeah, I got the idea. It's more like a commercialization kind of approach. Yeah.
Yes, because in general, you will see that for the next 9 challenges, as I said, it's very ambitious, and the technology is absolutely fantastic in terms of amount of technology. It's very complex, and we don't expect students or participants. We don't expect them to not reinvent the wheel, but we don't expect them to be able to work on technologies that are so complex. They really should look out for what exists, and from that they should decide how to market it, how to commercialize it, how to enhance it, and where to use it. Okay.
Yeah. Thank you.
Sure. So
just to add to this, I'm putting this right now. I'm uploading this document in the chat, so you'll have it. But the participants are using a business model canvas, basically. It's divided, it's pretty standard. It's really what is your value in terms of, what is your added value in terms of either technical or organizational. What are your key partners? What are your customer segments? The key resources that you have, and kind of not to be disconnected from the market. Basically, what is the basic cost structure, and the who will pay basically for the service? Also, to try to get them engaged also in the business model. But I mean, of course, in 24 hours, they cannot, they cannot develop everything. But this is for the business part. And some challenges, I mean, it really depends. You will see the list of the challenges. Some challenges are more business oriented, some are more technically oriented. And the scoring grid, which I will also put in the chat, it's kind of, participants are going to be assessed on both, basically, on both technical and business, and the way they manage or they incorporate the business components in the pitch, basically, in the solution that they present. So yeah, just to give you that, and I'm uploading also the scoring grid, so you know on which base they will be assessed. And it's not just students, and the large majority of participants are students, obviously, but it's really open. I mean, the only age limit, you know, it's over 18, and there's no age limit up. So it's open to anyone interested, you know, in space tech, regardless of profile. So we can also have teams, mixed teams, basically mixing students, startups, entrepreneurs, or any curious, you know, who likes, who is into that.
Okay.
I think you can go ahead, Walter, with challenge number 2.
Yes, let's go for challenge number 2.
Satellite data for a resilient planet. We're essentially moving public health surveillance out of the clinic and into orbit. The core innovation is the application of high-resolution satellite imagery for disease tracking. The idea is to use these powerful orbital assets to continuously monitor and track how diseases progress and spread across our planet. The job is to take the raw satellite data and analyze a multitude of variables that contribute to disease spread. This includes factors like population density changes, vegetation, water presence, local climate, and temperature. Such elements drive disease proliferation. Use of AI to process these colossal amounts of satellite data will enable to uncover patterns and trends that regular analysis would miss. This will help making precise predictions regarding disease outbreaks. Gaining an analytical understanding of the interaction between the disease and its environment is key. The goal shifts from reacting to outbreaks to predictive epidemiology. Understanding the conditions that contribute to disease emergence and evolution can help saving lives. Imagine identifying a potential outbreak weeks or even months in advance. This allows for the deployment of effective strategies to mitigate the impact of diseases. The idea is to correlate disease dynamics with satellite-derived data on land use transformations, evolving agricultural practices, and the state of natural resources. Understanding these links provides insights into how human interaction with the environment influences public health. Factors like pollution and habitat loss aren't just ecological problems. They are significant amplifiers of disease outbreaks. This initiative will facilitate international collaboration, creating a framework for sharing knowledge and resources. The output of this project is to enable more informed decision-making to enhance global resilience against threats. Your challenge is to determine the optimal satellite observation technology, to devise a strategy for data management and analysis, to establish connections with industry and governmental organizations. Finally, to present a comprehensive business plan for developing a successful company.
So this was CNES challenge number 2. As you can see, this is quite different from the previous one. So we go away from something I would say tangible, such it was antennas. Now we're going to something more of a data treatment. So for this, as we have said, the goal really is to see how you can cross-link a whole bunch of different sets of data and a lot of data, how to cross-link them, how to make connections, how to analyze them. So if you have any questions about this challenge, I will be happy to answer them.
Hi, Lex again. Sorry,
Yes.
is there any other people want to ask? I have a question that so within this challenge, what kind of data sets you would provide to the participants?
Can you repeat, please? Sorry.
The data
sorry.
sets, Walter.
Yeah.
The data sets, I imagine, such as Copernicus data sets. You had that in mind?
Indeed, yes. Yeah, for the data set, yeah, basically, well, it's part of the challenge actually, is to see where you can get data, and it's not that difficult, but you can get data from Copernicus indeed, and especially what kind of data you're going to look at. In the presentation, we mentioned data about deforestation, but of course you have data from the climate. This is obviously one of the prime, driver. And you can have data about let's say how the economy of a country is going, how the exchange between countries. You can really cross-link a whole bunch of data, not only from satellites, but maybe from many places. And the idea is to see what drives really the spread of viruses and other diseases, how to prevent, and how to model how they can evolve. And this has really, I would say, a lot of implications, and at the end, you can really save lives, and this is really one of the important factor in this challenge. I remember, I think it was 2 years ago, there were a group, I think from Switzerland and from Spain, group of girls. I don't know if you recognize yourself. They were studying medicine. They were doing medical studies, and they were in the competition, and they were actually working on, I can't remember really, but something related to some medical fields. And this is very interesting because the hackathon is not just about mechanical engineers, aerospace engineers, but it's really about anyone who think he can contribute to the field. Really, anyone can enter the hackathon, and this is one of the nice points of this competition.
I think you can go ahead, Walter, with
Okay.
challenge number 3.
Okay, let's go.
Redefining frontiers. Self-sustained space pioneers. The core principle is autonomy. We aim to maximize the use of local resources and employ rigorous resource recycling. The less we have to launch from Earth, the faster and cheaper we can work. The use of in-situ resource utilization is key. On the Moon, regolith can be the primary construction material, processed into habitats, infrastructure, and crucial radiation shielding. On Mars, the soil and atmospheric components can be used to build and maintain the base. For power, solar arrays on the Moon can be used. For Mars, power can be harnessed from the local atmospheric resources. Human crews will not be building the base. Advanced robotics will. Autonomous rovers will be used for surface tasks, like resource extraction and construction. Aerial drones can be used for surveying and maintenance. This automation ensures a constant and efficient workforce that reduces human risk. To facilitate rapid growth, deployable structures are critical. These are versatile habitats and workplaces designed to be expanded or reconfigured quickly. This inherent flexibility allows to accommodate changing mission requirements, reducing the time and resources needed for initial setup. Every core technology, from the ISRU processors to the deployable habitats, must undergo complete terrestrial validation on Earth. Your challenge is to propose applicable ideas and technologies in one of the presented field, to identify potential private and governmental partners who can contribute expertise, funding, and resources, such as space agencies, aerospace companies, research institutions, and technology providers. Finally, to develop a business plan that outlines the key elements for success, including market analysis, funding strategies, and revenue models, to ensure the success of this venture.
Okay, so that was CNES challenge number 3. And if we go back a little bit, you see it is a very ambitious challenge with many topics that are covered. And we are not expecting the teams to cover the entire topics. It's too broad, but if they can, these are leads, if they can work on one of the topic, for example, deployable structures. CNES is working actively in the field of deployable structures. This is deployable structure is actually again, in terms of business, is a very interesting topic. You can really, there is really room for companies to create such deployable structures. And we are talking about space pioneers, Mars and the Moon, but deployable structures on Earth, they are vital as well in terms of a catastrophe or in many areas as well. We are also talking about robotics with aerial drones, surface rovers. Again, it's not because we are talking about Mars and the Moon that you should not think of such rovers to be used on Earth. Robotics is a huge field with a huge set of applications from say surveillance or for going into sites that are, I don't know, contaminated or whatever. There is one other field that is important, is about ISRU. It's in situ resource utilization. We mentioned something about regolith. Regolith is the soil you find on the Moon. And one of the ideas that was actually worked on in the last hackathon was a very good idea, very interesting, was on how they would process the regolith on the Moon, how they would turn the powder, the dust, into something more than bricks to be able to construct habitats. So you see, you have room for many topics, and there are plenty of opportunities to actually make startup companies from these. So now, if you have any question.
So you see the diversity of challenges. I mean, people will pick, they will pick basically what relates more to them. But this was really an idea of the CNES to keep this diversity.
Yes, indeed. And
as well to say, yeah, in this specific challenge, they can also pick, either work on deployable and adaptive structures that can be also used on Earth in complex environments. And as Walter said, it's, I mean, there are many applications for business entrepreneurship, basically based on that. If there is no other questions, perhaps Walter, go on to challenge number 4.
Okay.
Strategies and revenue models. Venture. Harnessing the sun. Empowering the stars. Our vision centers on a large satellite or station equipped with huge solar panels to harness the sun's energy. This hub functions as a central power source in space for orbiting assets. Wireless transmission technology can be used to safely beam energy to satellites as they pass by. Alternatively, for a deeper charge or maintenance, satellites can dock directly with the hub's ports. The goal is to create a sustainable and renewable energy solution for the entire satellite ecosystem. The hub will reduce the reliance on finite onboard fuel and batteries. It will extend the operational lifespan, maximizing the return on investment for every asset in orbit. This also leads to higher efficiency. Satellite designers can shed the mass and volume previously needed for heavy batteries and fuel, dedicating that capacity instead to scientific instruments, propulsion, and so on. It means better, lighter satellites. This creates a truly sustainable and resilient space infrastructure. By centralizing power and utilizing a renewable source, this ensures long-term satellite operations and growth of the space economy. Your challenge is to develop a marketing and pricing strategy to attract potential clients and partners, to create a roadmap for implementation, including timelines and key milestones, to identify key partners who can contribute to the project's success, such as space agencies, commercial spaceflight companies, satellite operators, and technology providers.
Okay, so that was CNES challenge number 4. So as you've heard, the idea is centered on power, how to power satellites in space. So here there is quite a lot of work on doing research on what is available already, what technologies are available, how they will be applicable, and really how to build a business model and with whom you could partner to basically set standards, for example, on how the technology would be used.
Oh, it's clear. It's quite clear, Walter. Thank you very
Yeah,
much.
it's quite clear. Thank you. But I still have a question. Sorry. Yeah, of course, for international, I think, or say for Taiwanese participants, it might be pretty hard to convince judges for example, we know many companies and if we can convince them to set up sort of business proposal or even move forward to conduct some experiment, I think that's very ideal within Taiwan. But for participants, they probably don't really know what's happening in Europe, and especially the companies in Europe. So if participants in Taiwan like use Taiwanese company as an example to showcase their solution for this challenge, is that okay? Or they should sort of use like European companies as an example?
Okay, so if I understand the question, okay, I agree with what you said. We just presented something that was really concrete. We talked about inflatable structures. It was very concrete, we really see that we can actually provide a good, a company can actually provide something that actually, can be sold directly, and it's in some sense easy to find a market. But now I agree, it's more of a, it's hard to convince judges probably, but it's more of a way of saying, okay, there is a need, for sure there is a need, and if we can set up something in space so that we can basically recharge our satellites. I mean, the market behind this is completely fantastic. In terms of market, in terms of science, it's enormous as well. There are so many implications. So actually, if in terms of market, actually, there are companies. I'm sure there are private companies, and that would be very, very interested in that technology if they can apply this to their constellation. Sure. So what we expect maybe from the participants is actually to come up with some idea saying, okay, we want to standardize how the energy is going to be transferred. We want to offer different types of energy transfer. So we mentioned two, wireless and docking. Maybe they can extend on this. So they do a search on what would be needed on a satellite for wireless transmission, how it can be set up, how can we standardize rendezvous between a satellite and a space station. So they really should create describe how this technology can be actually set up, and if they can already convince the judges and convince partners later that this project is actually very viable, and the company who actually, even if you don't create yourself all the elements, it's about partnership. If you have identified all the partners and you have a plan, I think already it's a very good start. And at the end, it's not about creating something again physical like a space antenna. It's something about going to people, going to companies, and saying that you want to create something with them, and how you have to convince people, you have to convince the judges, and you have to convince your partners. But as I said, whoever can master this can actually probably have a pretty good, I say, company. You can really build something pretty big with this.
Thank you, Walter. Thank you very much.
Okay.
Okay.
Let's go on.
Stellar Library, your source for celestial information. We are now going to talk about the topic of data fragmentation. Imagine a space station as a universal librarian and switchboard. This will be a single, massive repository, receiving and storing information transmitted from every corner of space and ground infrastructures. This will house everything from scientific observations to precise locations of every satellite. The sheer volume of data is immense. The value of having centralized and standardized data is limitless. This hub will provide instant access to critical data, allowing satellites and ground crews to exchange data efficiently. This can provide timely warnings about imminent threats, ensuring safety. The financial benefit is huge. This ability to use shared knowledge avoids costly sensor duplication, saving on launch mass and development time. This interconnected network will enhance safety and coordination. A clear, synchronized view of the orbital environment will help in traffic management. This will also help faster responses to potential threats. This project promotes a collaborative, shared knowledge model. This will contribute to the long-term sustainability and advancement of space exploration. Your challenge is to propose relevant services that cater to the needs of your target market, to identify an appropriate business model that ensures sustainability and profitability, to pinpoint key partners who can provide strategic value and support.
All right, so for this challenge, so as you've listened, again, the idea is again, it's not about building something just like before. It's not about building something. It's about providing a service, and what we are expecting from the participants is to really come up with a business model and to come up with an offer saying, okay, here is the offer. We want to centralize data. So as we have presented some use cases, but you have many. How can it be exchanged is what we also expect. Maybe set some standards, and this can be for the entire community very useful because you will not duplicate onboard sensors. A satellite who is doing Earth observation, for example, on ground temperatures, can share its data, and with another satellite doing I don't know, even we mentioned something. It was something about the study of the viruses and diseases, and this is a very good actually example. It's this hub will actually centralize all the data from many sources, and you have to go to this hub and pick up all the information. So this is really a central point, and one key element as well is if all the satellites could give their location, then you have in real time the location of all the satellites, and this would actually enable well, avoid collision in space. So what we expect again from the participants is really to see what they could what services could be proposed, and how they would offer their service, because the idea again behind is for each challenge is to demonstrate, and you will see that in what Magali is going to upload. It's you have to demonstrate how sustainable your business model is, and how profitable it can be. You really have to convince the judges, regardless of the technology, regardless of everything, what really if your startup company can actually live up, and if you can actually develop a business from the work. So if you have any questions.
Yeah, it's really this entrepreneurship framework. I mean, it's this umbrella that frames really the ActInSpace competition since the start, actually, and since 2014.
Okay.
Challenge number 6.
Yes.
Yeah.
So we're now going to talk about
Forests from above.
green space.
One of the planet's most persistent and critical environmental challenges is deforestation. Despite all the global efforts, deforestation continues relentlessly. This crisis contributes to climate change and biodiversity loss. It also undermines global efforts towards sustainable development. The idea is to use an AI-powered monitoring and prediction system to gather, analyze, and cross-link large amount of data from Earth observation satellites. This system provides real-time, detailed tracking of forest changes. It will utilize AI to predict areas at high risk of future deforestation. The idea is to look at a satellite image and not just see tree loss, but understand the cause. We must distinguish between natural, cyclical changes, like a forest recovering from a fire, and irreversible, human-caused deforestation, providing an accurate picture of illegal or unsustainable activity. The models should look beyond geography. They should incorporate economic, political, and social factors. The goal is to model and predict where the next deforestation hotspots will appear. This tool shall provide the objective data needed to help communities and governments balance the essential need for conservation with their legitimate economic development needs. It's about smart, sustainable land use planning. Your challenge is to give explanations on your monitoring and prediction system, to create a sustainable business model for ongoing operation, and for securing long-term funding for system maintenance and updates, to identify key partners who can contribute to the project's success, government agencies, non-governmental organizations, indigenous communities.
All right. So for this challenge, here it's I would say it's a bit, this challenge is not as complex in terms, it looks not as complex as some other challenges we have presented before, as it's very easy to grasp the concept and see that the idea here is really to help fight the deforestation, especially the illegal one, and really to help governments, and to help local communities on how to manage the forest on Earth. I'm sure there are many there are participants from many countries that are directly concerned with the problem of deforestation, and creating a company that could actually provide a service that is saying we think that in that place there is something illegal going on, well, to a government. I mean, that's a service, obviously. That would be very interesting, and as well to say to a government or a community, saying that here we think that this place over here is actually all right if you want to actually build something, for example. So again, the idea here is how you would process the data. What would be your added value? So we talked about AI, so about modeling, because it's really, there are many parameters that you should consider. The better your model, the better your prediction, and the better your service you can actually provide. So, as I said again, this we have said earlier that we're really going to Mars, Earth, forests, diseases. It's very broad, and we hope that everyone can actually find something very interesting. And for sure, this challenge is pretty obvious that a company providing such services would probably be quite profitable. Well, if you have any question now.
I think it's a great challenge, and I think perhaps the trickiest part is the business model of this challenge also, and including private partners who can be like extractive timber companies who have to give account also of what they do in terms of deforestation and then reforestation. But it's I mean the one of the trickiest part also in this challenge to me when I look at it is really the business model also, not to be subsidized and to find the market. And there is a huge market in the everywhere. It's a global challenge indeed.
Yes, I agree with you. I think there's another factor you pointed out in the last sentence, indigenous community. Yeah, could you say something about that? Why it is included in a very commercial kind of competition?
About indigenous communities, you want a word, right?
Yes.
Yes. Well, they actually indigenous communities actually are the first persons. They're the first victims of deforestation, because well, they are by definition the people who actually live next to the forest and who are first impacted. So they're the first persons to actually be concerned directly with deforestation. So I think that it's very important for government to protect its communities and to protect especially its indigenous communities, and if it's really part of the equation here. As I said, these are the people. I mean, deforestation actually destroys. So you actually destroy biodiversity. You destroy cultural diversity, and you actually, as I say, if you destroy their habitats, if you change the ecosystem, the ecological system, all these communities, they will disappear, and I mean, as a whole, the Earth will lose.
Thank you, Walter. I think we can move on to challenge number 7.
Secure and sustainable space operations. The goal is active debris removal technique with autonomous capture and controlled deorbiting. Space debris range from inactive satellites to spent rocket stages to fragments. It is a problem of speed with orbital velocities and then huge kinetic energy. This poses a non-trivial and constant risk. It demands continuous tracking and collision avoidance maneuvers. The cascade effect, also known as the Kessler syndrome, may create a self-sustained chain reaction that could render the most valuable orbital highways unusable. Managing debris is not just good practice. It is about maintaining a safe and sustainable space environment for everyone. It is a matter of global economic and security importance. The biggest technical challenge is the capture itself. These objects are often large and tumbling wildly. Using AI and sensor fusion, a vehicle could autonomously rendezvous with and secure these pieces of debris without human intervention. While robotic arms are ideal for capturing large, stable structures, there are other specialized systems, like nets or magnetic capture, for smaller, unpredictable fragments. The ability to switch tools is essential for versatility. Once captured, the debris will be attached to a reusable propulsion unit, for controlled deorbit maneuver. The debris will burn up safely in the atmosphere over an unpopulated area. Your challenge is to explore the feasibility of a startup company, to analyze your competitors, including their technologies and market positioning, to secure the required funding. Consider sources such as governments, venture capital, and private investors. To find with whom would you collaborate? Potential partners could include space agencies and satellite operators. Present your business model, potential revenue streams, and marketing strategy, ensuring a solid commercial offering.
Okay.
I have a question, Walter, on the size of the debris. Is there a max size? To my understanding, these targets, the smaller ones, right?
Yeah. As we said, even fragments, I mean, even bolts, small fragments, they really pose a threat. A bolt is enough to actually destroy a satellite. So small fragments is a problem. Of course, if you have a large dead satellite that is widely tumbling, this is going to be basically the technology is going to be different. If you have a big large satellite, or if you have a small fragment, you can use nets. You can use in one case you can use a robotic arm if it's large. In another case you can use magnetic traps, nets if it's more than fragments. But they all represent a risk. And well, the problem is if you have even one fragment can actually it's this Kessler syndrome can really create this cascade effect and generate a whole bunch of other fragments that are going to hit and decompose and create more fragments, etc. So again, here we're not expecting the participants to come up with a full solution with the entire set of answers. One topic could be a startup company focused on fragments, saying, okay, we have developed a spaceship, autonomous spaceship that is basically acting as a net to capture fragments, or we have developed we want to develop a small vehicle that will actually be able to gather the fragments and to launch them into the Earth atmosphere. So we're not expecting participants to do the full set, but if they can provide some answer and saying how they would, again, what's very important for all the challenges from all the participants and all the challenges is to be able to convince the judges that their solution is economically viable, and to be able to give some milestones on it's not in 24 hours they're going to give us the entire technology and all the solutions, but to give milestones about technologies, when it will be ready, how long it will take to finalize, when it actually the service can take place. It's really about convincing the judges that there is actually ground to create a company and that is going to be profitable as well. So what's actually again funny is that we came from deforestation, so something very underground, and now we're back into space talking about space fragments. And this is what's very nice about the hackathon is I think everyone can actually find a subject that is very interesting or where they can get inspiration.
Thank you, Walter. Thank you very much. We can switch to challenge number 8.
Okay.
Thank you.
Space beyond boundaries. Private stations for new age. The goal is to develop and operate private space stations that shift space access from a government endeavor to a viable commercial service. The smaller robotic platforms are key to testing, technologies, servicing, and niche high-value markets. Services for orbital platforms could be advanced materials research, specialized manufacturing, and a new era of space tourism. Securing financial backing could be through a strategic mix of private investors and essential government contracts. Utilizing cost-reducing solutions in construction, launch, and operations would help to manage significant financial costs. Partnering with other companies and space agencies to utilize shared infrastructure and resources, reducing unique developmental burdens. Some technological key points are life support systems with closed-loop environmental control, cost-effective propulsion for logistics and maneuvering, modular building techniques. Consider risks from radiation exposure to micrometeoroid and orbital debris impacts. Think of redundant safety protocols that protect the crew and the equipment. Multi-layer shielding, continuous real-time environmental monitoring, system that can recover from operational failures. High-risk assembly could be conducted utilizing robotic missions, reducing immediate human exposure. Scheduled crew rotations will focus on sensitive system integration. Your challenge is to address one or more of presented topics, to make improvements from the proposed ideas, develop your own ideas, schematics, working principles, and options to offer some solutions, to present a solid business model, potential revenue streams, and marketing strategy.
All right, so this is probably the most ambitious challenge so far. Obviously, we're not expecting the participants to come up with the full private space station. This is completely impossible. But here we are mentioning about some technological developments. So maybe they could come up with. We mentioned efficient habitat construction. So basically, ideas on how they would see such a space station, and again, how they would propose, how they would commercialize. We mentioned space tourism. Space tourism is actually a market. It actually exists, and there are people ready to pay for the ultimate experience, going to space or going on stratospheric flights. So obviously, setting up a company, for example, that focuses on space tourism would be a very interesting, I think, presentation from participants, and trying to convince judges that they can partner with people and they can offer a service. How much a ticket will cost? I mean, how much, how they would actually monetize it, how they would make a business out of it. As well, we mentioned researches on materials. Obviously, well, there is on materials on the biomedical aspect as well. We didn't mention it, but that's important as well. How they would find a business model to offer to a medical company, saying, okay, we can we can give you some zero gravity time. So what would be the business model for this, for example? So again, we're not expecting people to actually come up with the, especially in 24 hours, in how they would build a space station, how it would look like, and how much it would cost in total. But if they can come up with some ideas and solution on life support system, on anything that is related to this, it would be actually already a pretty good step forward.
Thank you, Walter. No, it's pretty ambitious indeed.
Yes,
Pretty
yes, we
ambitious.
realize this, but
it's tomorrow actually. It's
yeah.
and it's already starting. Yeah, you can move ahead.
Step at a time. Long-duration space travel is the most profound set of logistical, technological, and human challenges we have ever faced. This involves two critical elements: the transit to Mars through deep space and the establishment of extended, sustainable habitats that act as our homes and operational bases in orbit. These stations and spacecraft must function as fully self-sufficient research laboratories and eventually as gateways that facilitate our push further into the solar system. The core problems are survival and human endurance. Astronauts must cope with isolation and confinement while being exposed to the continuous radiations. To manage mental health, we could provide access to immersive VR experiences, allowing astronauts to step out of their confinement. Regular high-quality video communications with loved ones are paramount. A scheduled relaxation and leisure time is needed. A resupply mission to Mars is impractical, so we must achieve logistical self-sufficiency. This means perfecting closed-loop life support systems, recycling water and air with maximum efficiency, and systems like hydroponics to reliably grow fresh, nutritious food. We are transitioning to systems based on robust, modular designs that are simple to take apart and put back together. Incorporating 3D printing and additive manufacturing to replace parts on demand, to reduce reliance on Earth. Your challenges: to ensure durability, reliability, and seamless integration of all complex mission-critical systems across extended periods. To make improvements from the proposed ideas, develop your own ideas, schematics, working principles, and options to offer some solutions. To present a solid business model, potential revenue streams, and marketing strategy.
All right, so we're still in space, and again, a challenge with many topics within the challenge, and there are many leads for each topic, and for more, there are many ways to actually create startup companies. I'll take just one item is the isolation and confinement. We mentioned, for example, psychological stress, how to fight against isolation. We mentioned VR experiences, video communications, leisure activities. Already, if participants would come up with just on this, for example, just on these ideas, just say how they would fight isolation and how they would guarantee mental health, that would be already very interesting. And what's very nice is that we're talking about space and exploration and Mars, but obviously you can actually also propose, a company could actually also propose ideas and products to fight against isolation and on Earth for elderly people, for example, or to how they could help people communicate. And so there is actually there is ground for a lot of startup companies. Obviously, we mentioned the problem of food supply, of recycling water. These are very interesting. Hydroponics in itself is a huge field, and already a startup company coming up with just ideas about hydroponics, how they would set it up, how they would, what service they would propose, how it would work. That's already very interesting. Finally, about we mentioned about additive construction, 3D printing. 3D printing could be used obviously to, so that you don't have to bring all the parts with you when you go on a trip, especially in space. You could actually use additive printing for creating habitat as well. So again, here, for a startup company, on all these fields, if you take them one by one, you already have a lot of material to actually work with. Obviously, here we present it in the space exploration orientation, but all these challenges, basically, if you take, this happens all the time. You actually develop a technology for one field, so for space, for example, and in the end, you actually use this technology on Earth, and vice versa. So I think that here we present many leads, many ideas that startup companies could actually use. And what we expect, as I'm repeating, but what we expect is really for people to come up with a business plan, a clear business plan, saying, here is how the company will start, will grow, and how much money we will actually make. If we can get charts on the profitability, for example, of the company, saying this year we might lose money, but next year we're going to make that amount of money, etc., etc. So if you really have a clear business plan, so that you can convince the judges that your company is actually worth creating. Okay.
Thank you, Walter. Thank you very much.
So the next challenge.
Guardians of the orbit, protecting our space, securing our future. Low Earth orbit is threatened by crowding and debris. The focus is on creating a structured, safe environment in space. International bodies, like the United Nations Office for Outer Space Affairs, plays a critical role in coordinating global efforts and establishing common rules. The issues are managing orbital traffic, protecting against digital threats, designing sustainable satellites, leveraging new technologies. For safety, the goal is to prevent collisions. This requires high-precision tracking, data sharing, and clear universally accepted protocols for safe orbital maneuvers. For resilience, we must adopt rigorous security by design principles to defend against digital attacks. Also, to protect from space environmental threats, we need a real-time warning systems to protect satellites and provide timely alerts for Earth-based infrastructure like power grids. For sustainability, we shall rely on technological innovation in advanced propulsion and autonomous collision avoidance to enhance the safety and longevity of the entire ecosystem. Your challenge is to find and explore strategies to mitigate risks and ensure the safety and sustainability of space activities. To select one or more items from what has been presented, and then present the business plan for your startup.
All right. So this was the final challenge, number 10.
Traffic controller, space traffic controller.
Yes, space traffic controller. There are many things that have been said in this last challenge. There are many topics, and once more, you don't have to do them all. You can actually concentrate on one of them. There is one topic that actually is very important. It's about cybersecurity. There are very profitable companies that offer some antivirus software for your everyday PC. But cybersecurity in space is paramount, actually, especially for well, basically to fight against attacks. People who, I mean, I'm not talking about military uses because that's one aspect, but even for broadcasting videos or satellite data for civil applications, there could be really devastating effects if an onboard computer would be actually paralyzed somehow. So actually, for people doing computer science, I think there is a very interesting business to actually create in terms of how you would protect satellites or whatever orbital asset you have. So that's one aspect. We also mentioned about space management, how you manage all the thousands of satellites that are orbiting. How do you, would there be a way to do a very nice algorithm with some AI maybe behind and to predict future collisions? It already exists, obviously, but actually to really offer a service so that any company who actually, again, who actually send, I don't know, satellites for TVs, for communication, if they could rely on one shared body who could provide a service about collision, that would be interesting. We also mentioned about in the threats, we mentioned about solar storms. Solar storms can really be a huge problem. This already happened, for example, in Canada, where solar storms actually crippled the power grid. So again, there are already there are services that already exist, but what we expect from the participants is to look up really what exists already, what exists for orbital safety, what exists for coordination, what exists for environmental threats such as solar storms, and on and on. We mentioned that there are international bodies like UNOOSA. They actually do some great job already. So really look at what exists, look at what you could provide, and surely there is space to create a new company. There is space to create a profitable company. So we give you all the ideas. We give you all the locks. Now you need to provide us with the keys, and you need to convince the judges. There are many topics. We have 10 challenges from Earth to Mars. We have in each challenge many topics covered. So again, you can really work on a tiny part of a challenge, really a tiny part. But if you can actually convince that with this tiny part you can actually have some really good idea, something that does not exist, or you can do much better than already existing, that would be really great. So I think I'm done with the presentations, and give if you have any questions, I'll be happy to answer them.
Oh, thank you. It was very clear, Walter. Thank you very much for that. Just I won't be long for keeping the time, but ActInSpace is really oriented market, entrepreneurship, and the overall aim. I mean, not all participants will create, their own startup or will join a private company to pursue the idea, but really the idea behind is to foster innovation, basically, in all, diversity of stakes that happens in space, in the moon, in Earth also, and that puts geospatial data or infrastructure located in space. They're just using that to solve the problem. So it's really about innovation. It's really about entrepreneurship. And we hope, as Walter said, we give you the keys, and then it's up to you and it's up to the participants basically to brainstorm collectively and to come up with something innovative and using basically the collective intelligence. That's really behind this whole hackathon thing. I want to add that the respect of intellectual property rights is very much it is very much concern of CNES. I mean, the idea is not to extract, out of young brains, basically, what they think, not at all. And these, if you look at the rules of the competition, this is really written black on white. So they're really, intellectual property rights are really respected. And that has to be said because it's not the case in all, international hackathon. So this has really to be said. I mean, obviously, participants can tap into a wide diversity of open source data. I'm talking about Copernicus. We talked about it, but there are many platforms actually that are made freely, and some partners also can make available certain data sets. I mean, European Space Agency was thinking of making available a specific set of data linked to the specific challenge, so that people can just tap into new data, I would say, to come up with their solution. So it's really an opportunity. And thank you very much, all of you, for attending the session. Thank you, Lex, for all your questions. This was this was very nice to hear.
Can I delay your time for like just 1 minute?
Sure,
I
sure.
can have one very super general question, not really about the challenges, but is it gonna be only one winner at the top of the competition?
There'll be, I mean, there is one grand prize. So that's the flight, in 0G. Then we have some partners who have specific prizes, like, for instance, the European Business Angels Network. They have a prize for promoting female entrepreneurship, related to space. Airbus has a prize also on innovation. In Extenso also have a prize. We have a diversity of partners. I mean, you can check on the website. And during the local editions, basically, the role of the local jury will be to identify the winner, basically the one who will qualify for the grand prize and who will compete for the flight in 0G, but also to make visible the other prizes, such as female entrepreneurship, innovation, etc. To say, hey guys, okay, you didn't win you didn't qualify for the grand prize, but that's okay. You have opportunity also, to compete in these other prizes, because these also are global. And I mean, of course, in Taiwan, I mean, if you have, through local sponsoring also, you can create your own local prizes. That's disconnected from the global prizes, who will be awarded in Bordeaux in France. But if you want to create your own local prize on, I don't know, blue economy or sustainable anything, I mean, you know, thematically, you can think of many things basically, but that really depends on your own ecosystem and on the local sponsoring that you can raise for the session.
Yeah, thank you. Yeah, we're talking to the potential sponsors that's visiting Porto.
Yeah.
It's really super great opportunity.
Very good.
So
No,
it's
very
a
good.
very indirect way to lure them in.
Very
But
good.
I think this has been a very good design for the competition. Thank
No,
you, Walter. Thank you for your time. I
Thanks.
think I will see you in no matter where you are, I will see you in Europe.
Yeah, we are. Yeah, we are.
For sure.
Anyway, thank you very much. I want to thank Walter very much for preparing and for all the presentation, and the others for attending the session. And this session will be, you know, available on replay on the website, so participants can be. As I said before, registration open on 3rd November, and so participants will be able to access, you know, our exchanges, basically the presentation Walter prepared, but also the Q&A, which also were great. I think they gave enough, you know, background information so that people can just pick and choose, and they know a bit more on what is expected from them. I thank you very much, everyone, and
Thank you.
and yeah, have a great day wherever you are.